Welcome students to the series of lectures on statistics. Today we are going to discuss a very important topic, that is probability distribution. Probability distribution. Now from here onwards, the journey will be very exciting and challenging because you're entering into probability distribution. And the probability distribution is one of the most complex discussion in statistics in CFA or FRM, or you can also say that it is one of the most complex discussion in the whole CFA and FRM curriculum. So you should be aware that in CFA, we call statistics as quantitative methods, and in FRM, we call it as quantitative analysis. So CFA and FRM aspirants, you should study probability distribution in depth because it will determine that how you understand other topics as well. Now, in this series of lectures on probability distribution, there would be a series of lectures on probability distribution. We'll first try to understand different distributions like normal distribution, log normal distributions, student t distribution, chi-square distribution, f distribution, binomial distribution, Bernoulli distribution, Poisson distribution. Perfect. But while doing so, you should always keep in mind why you are studying any distribution. Why any distribution is important in the world of CFA, FRM, or finance as such. Why? The reason is very simple, that it is important in finance that you predict, you forecast stock returns, you forecast cash flows, you forecast interest rate, valuation, stock prices, and many other financial entities, okay, or many other financial values. Now, prediction forecasting becomes easier if you know that an entity follows certain distribution. It is a very easy exercise to forecast an entity if you know that the entity follows certain distribution. For example, if you know that the stock price follow log normal distribution or stock return follow normal distribution, it becomes very easy to say that the return of the stock will be between 5% to 6% with 95% probability, or it would be between 10% to 12% with 80% confidence. So you can see that if you know an entity follow certain distribution, if you know that stock return follow normal distribution or stock prices follow log normal distribution, your prediction and forecasting become much easier and much more robust. And that is why you are studying probability distribution in the CFA or FRM curriculum. Now, when you start probability distribution, you will study around 8 to 10 distribution, depending upon whether you are studying CFA or FRM. For example, in FRM, you may have one or two additional distribution. So approximately 8 to 10 distribution will be covered. Today, we'll try to understand that at a very high level, what distribution you will study. So when you enter into probability distribution, you will study two types of distribution. As you see here, you will study two types of distributions. The first is discrete distribution and the second is continuous distribution. Discrete distribution and continuous distribution that you have to study. In discrete distribution, you have to study three main distribution. Actually, there is also a fourth one, but the three is Bernoulli, binomial, and Poisson distribution. You also will study uniform discrete distribution. So I'll also introduce uniform discrete distribution. Similarly, in continuous distribution, you will definitely study normal distribution, log normal, student t distribution, chi-square distribution, f distribution, and again uniform continuous distribution. So you will have uniform distribution in both discrete and continuous, which I have not written here. Now, what you need to understand at this stage is simply this, that Bernoulli, binomial, and Poisson falls under the category of discrete distribution, whereas normal distribution, log normal, students, chi-square, and F distribution falls under the category of continuous distribution. Discrete, continuous. Now, why discrete and why continuous distribution? Why the categorization is there? It depends upon the entity that you're trying to predict. Is it a discrete entity or a continuous entity? For example, if I say, let's talk about the roll of a dice. We all know that roll of a dice has six outcome, 1, 2, 3, 4, 5, 6. So the roll of a dice is a discrete entity, or the outcome of the roll of a dice is a discrete outcome because the outcomes are finite and countable. The outcomes are finite. and countable. If the outcomes are finite and countable, I'll call that entity as discrete entity or discrete random variable. So roll of a dice is a discrete entity. Okay, again, if I say toss of a coin, the outcomes are finite and countable because there are only two outcomes, head and tail. If I say the stock price will rise or fall or remain constant, again, only three countable finite possibilities. So you can count the number of outcomes which are finite and countable, and that's why these entities are called as discrete entities. However, when you enter into continuous entities, you cannot count the outcome. For example, if I ask in the continuous entity or continuous random variable, if I ask you that what are the different possible stock prices, you will say that stock price could be zero, it could be 0.001, it could be 0.002, or it could be 0.01, it could be 0.02, or it could be 0.03, so on and so forth until and unless you reach 1. And then from 1, it is 1.001, 1.002, 1.003, 1.004, so and so forth till infinity. Is it countable? Is it finite? No, it is infinite. So you understand that it is a continuous random variable because it's take continuous value like 0.001 and then it is 0.001 and 1. Similarly, consider a rainfall in a city. Rainfall could be 0 centimeter, 0.001 centimeter, so and so forth. So you cannot count the possible outcome of rainfall or stock prices or stock return because it varies from 0 to infinity or minus 100 to infinity. For example, in the case of stock return, it varies from minus 100% to infinity. Definitely, it'll change the stock return to log normal to normal distribution, then it will be minus infinity to infinity. That is a very different discussion that we should not discuss today. But if we talk about arithmetic return, it varies from minus 100% to infinity. Therefore, because these outcomes are not countable, we say they are continuous random variable. Why? Because their outcomes are continuous, their outcomes are infinite. So, therefore, discrete distribution and therefore continuous distribution. Discrete distribution and continuous distribution. Now, in all these distribution, I'll stop here, but remember, keep in mind, in all this distribution, you must be very good. You must be aware of these four things. First, when you should use these distribution and when you should not. Second, what is the probability density function of each distribution, or is it even applicable? Third, probability mass function of each distribution and cumulative distribution function. And the last, you should be aware that how to use these distribution for forecasting, for prediction and hypothesis testing. So you should be aware of PDF, PMF, CDF, and also when you can use this distribution, when you cannot, and how to use this distribution for prediction and hypothesis testing. With that, I'll pause here. This is the first session which introduced probability distribution in your life, in your curriculum. After that, we'll enter into the discrete distribution. We'll cover some discrete distribution in the next session. Thank you. Have a nice day.